Hello guys, hope you're doing well and you're healthy. I am Gyanendra and today we'll be talking about something very interesting which you'd find in organic chemistry. We will be talking about a reaction under a mechanism, to be more precise, called a nucleophilic substitution reaction, but not with unimolecular mechanism, neither with bimolecular mechanism. What we are going to look at today is neighboring group participation mechanism of SN reactions, substitution reactions. So the name of the reaction itself can be seen here in the screen which I'm sharing. As you can see, the name here is a nucleophilic substitution reaction by neighboring group participation. So what actually happens here is you'd actually have a neighboring group, a group which behaves differently, which itself behave like a nucleophile, or you can also call it an internal nucleophile. So let us first look at a substrate which can give you a mechanism, a reaction, which would not be same as that of SN1, neither of SN2. So let's look at the substrate first, and then we will be able to talk about it better. So this, guys, is the kind of substrate which can show you this unique mechanism. Unlike how we would have SN1 and SN2, the behavior of this reaction would be many times different. And one very unique thing which you should note here is the speed of this reaction, guys, is 1000 to 600 times faster than that of SN1 or SN2 reaction. So many times in a question in IITJEE or any competitive exam would be popping up from the way that they would ask you which reacts faster. In that time or at that time, this thing or this theory or this mechanism would help you. If there is an internal nucleophile, if there is a group which can provide electron pair, then there can be something called neighboring group participation in the nucleophilic substitution mechanism. So let's understand what it does first of all. So it increases the rate of reaction that occurs due to the participation of the neighboring group. So the first thing which it would do is increases the rate of reaction many times, guys. And that is the most unique thing about it. It increased around 1000 times to 600 times. Now let us understand what is the requirement for this kind of reaction. So the requirement is very simple. There has to be an internal nucleophile. There has to be an internal nucleophile. As you can see here, the first point, there has to be an internal nucleophile present in the substrate for reaction to occur. So let's first see what an internal nucleophile is. So if you look at this substrate here, which is marked in the pink color, you'd find that this sulfur atom, which is carrying an electron pair, can actually give its electron pair, and it can also behave as a nucleophile, not a nucleophile from an outside source, but a nucleophile which is already present inside the substrate. And that is how this whole thing differs, the whole reaction differs. So let us look and understand what is SNNGP. Okay, so we'll first look at it, but before that, we should also understand what are the things that you need to know in order to understand this. There are two conditions, guys, which will help you to understand that there would be an SNNGP reaction. First condition, there has to be an internal nucleophile present. You should have an internal nucleophile, which should have a unshared electron pairs or a double bond, which should have an unpaired electron pair or a double bond with it. If it does not have an unpaired electron, and if it does not have a double bond or something, then you would not have this kind of reaction. The minimum requirement which you need to have in order to have a nucleophilic substitution reaction via neighboring group participation mechanism is, the basic requirement is very simple. A substrate which has a group in the position, in the whole molecule, where you have extra electron pairs also. The second point here is an anti-position. We'll talk about this position and these things in the next. What we need to understand is what will happen in this reaction. First thing which you need to know, that will be the product, that will be the thing which you'd find in this reaction is the rate of the reaction would be enhanced around 1000 times, guys. And there would be a different point, a different way the product will get formed. Unlike in SN1, where you get a racemic mixture, and in SN2, where you get inverted product. What you will get here is the retention in configuration. Remember, this would only be applicable if the substrate is going to be chiral. That is it, guys. So this is the first and the second point. The third point is about the nature of the reaction. This reaction is unimolecular. Let us understand and observe how this reaction actually occurs. So let's for an example see that this reaction in front of you is the actual reaction which is what we call as SNNGP. Now let us look at the mechanism of it and understand it better, properly. So the first step of this mechanism involves the donation of this electron pair. So as you can see in the step 1, these electrons would be donated to the Cl atom. And once the electron is being donated to the Cl atom, what you get is a molecule which is a cyclic substance. This kind of cyclic molecule would get generated, guys. And this cyclic molecule obviously is very, very unstable. Very, very unstable. And once the cyclic molecule gets formed, the reaction will try to move to a different step very fastly. And that is the reason, that is the catch here, that is the reason why the reaction occurs very, very fastly. So let's look at the second step of the reaction. This cyclic intermediate, this cyclic sulfonium ion, a sulfur positive ion, is the major thing which makes this reaction move so fast and give us the product in a much faster time than that of SN1 or SN2 reaction. Let's see what happens in the next step. This H2O, you'd have electron pairs on this oxygen. These electron pairs will be easily donated to this bond breaking. And once this bond gets broken down, as you can see over here, once this bond gets broken down, which will be very, very fast. And the mechanism which you'd follow here would behave like SN2 mechanism. So, what actually happens is this electron pair will shift back to the sulfur, and ultimately you'd get this molecule here. And this molecule, as you remember from the other things which you would have learned earlier, that this molecule is the product here. But remember, again, you have a positive charged oxygen atom, which is very, very unstable. In organic chemistry, you would have heard, or in anything in chemistry, you would have heard that a positive charge, an electronegative element, is like a very dangerous thing, guys. There are two very dangerous things in chemistry. One, positive charge on electronegative elements. And second one is negative charge on electropositive element. If you get that kind of situation, the whole thing will rearrange itself in very fast manner to get to a stable scenario. So let's look at what actually happens next. So in the next step, what actually happens is this H2O molecule, the electron pair of the H2O molecule would attract this hydrogen atom, which you can see over there. This hydrogen atom will be taken out, and once this hydrogen atom is taken out, you'd end up getting the final product. And you'd observe one thing. The same configuration as what you had in the beginning would be forming in the final product. That is a result of getting inversion 2 times. As you remember, in SN2 mechanism, the product will be inverted. So there are 2 steps which you have as of how you would had in SN2 mechanism. The same has occurred here, but 2 times. Like if inversion occurs 2 times, what would you get? Obviously, there will be a retention. So that is why in this whole mechanism, the retention of configuration actually occurs. And this is the reaction which we call as the neighboring group participation. And this is why, because of the formation of this intermediate, it has actually increased manifold. The rate, the speed at which the product gets formed has increased manifold. Second point to know and remember here is there's a retention of configuration, guys. So keep these things in your mind and stay healthy. This is the result for today.